Good morning, ninth grade. This video is to help you review the different tree diagrams and also the different types of events, whether it's independent or dependent on the initial probabilities. So we're going to start with something that's independent, looking at whether the Pistons versus the Bulls, who's going to actually win the game. So there are some probabilities that we need to write down. The Pistons have a player at the free throw line, and he has 2 shots to make. He usually makes it. So the probability of making the basket, making that free throw, would be 62%. But then the probability of missing would be the other part of 100%. We have to assume that the player either makes it or misses it 100% of the time, one of the two. So they have a 38% chance of missing it. And so what we want to look at is one attempt, and then a second attempt. 2 free throws, and they're tied. So the Bulls and the Pistons are tied. So if they make the first one, they could win. Or if they make the second one, they could win also. Or if they make both, they just won by 2 points. So first, let's create the tree diagram. And we have answered this first question, by the way. What is the probability that of the Pistons player at the free throw line misses the shot? And that is the 38%. So now we're going to create a tree diagram to show what could happen. So for the first attempt, we could make it or miss it. And notice that I'm going to put the percentages as decimals. 0.62, 0.38. As I mentioned in the Desmos activity today, it will make calculations a lot easier. So if we make it, we have a 62% chance, 38% chance of missing it. But that's only the first attempt. If they make that first one, that second one could be a making it, or it could also miss. But whether they made it the first time, it does not affect whether they made it the second time. So this is an independent scenario. And so the same probabilities get put along the branches. And the same, if they miss the first shot, they could make the second one or miss the second one. So again, the probabilities are the same. They do not change because they're independent events. First shot, second shot. So now let's answer this last question. What is the probability that the Pistons win the game? Well, let's get our total probabilities calculated. So I'm going to slide up my notebook so you can see my calculator. And so first, if they make it both times, they have a 38% chance. I'm going to round it to the nearest percent. They make both shots, 38% chance. But then if they make the first one and miss the second one, let's look at that. That is about a 24% chance. But then say they make the first one, they'll still win. If they miss the first one, but they make the second one, that crowd is going to go wild and they will be happy that they won they made that shot. So let's look at that probability. Notice that it is just the reverse of making and missing the second. It's the same as missing the first and making the second. It's just made one of the times. So this is the same probability, about 24%. Okay, now here's where they would lose. So 0.38, oh, and that should be an 8. Apologize for my typo. Correct that on your diagram. So 0.38 times 0.38, 0.144. So about a 14% chance of losing. Oh, if they're tied, all they need is one shot made and they win. So if we add up all the probabilities of them making 2 shots, making one of the shots, then we know their total probability of winning. So probability of win, we'll add the 38%, the 24%, and the 24%. So 38 plus 38 plus 24. Oh, I'm sorry, 24 plus 24. 86% chance that they will win the game. Now, another way to think about it, probability of a win, is just taking 100% minusing the loss. And that's 100 minus 14, which is also 86%. But now let's look at a dependent scenario. A dependent scenario, the probabilities change according to what it happens to begin with. So let's look at this example. So notice that we've got a box of candy. Dependent. So we have 6 grape and 3 strawberry. Pieces of candy. And Carla takes one piece from the box and she does something very important. She eats it. So that means that each time she picks a piece of candy, each choice is eaten. So the probabilities will reduce every time she picks a piece of candy. And notice that she is choosing 2 pieces of candy. So similar to what happened up here, there was a first free throw and a second free throw. Down here, we will have a first pick and a second pick of Carla's candy. So the first pick, it could be grape or it could be strawberry. And then the second pick could be grape or strawberry. And if they picked strawberry the first time, the second pick could be grape or strawberry. So now let's look at the probabilities. Notice that there is a total of 9 pieces of candy. Now I know some of you will be eager to reduce fractions, but because this is a dependent scenario, we need to be careful and not reduce until the very end. So the probability of grape is 9 out of 12. And the probability of strawberry is the other, 3 out of 12 pieces of candy. So now the first pick, if it's grape, there's a 9 in 12 chance that Carla picks grape, and a 3 in 12 chance that she picks strawberry. But once she picks a piece of candy, then there's only 11 pieces left. So notice that all of these probabilities are out of 11 pieces. Say the first one was grape. Then there's only 8 grape pieces left in the box. Suppose the first one was grape, then all of the strawberry are still in the box. And notice 8 plus 3 is 11, and 11 over 11 represents all the possibilities for the second pick if the first was grape. But now, what if the first was strawberry? Well, we still have 9 pieces of grape candy. But if the first one was strawberry, then there's 1 less strawberry in the box. So there's 2. So now what we're going to do is multiply to get the total probabilities. 12 times 11 is 132. So all of our probabilities will be out of 132. So 9 times 3, 27 out of 132. And then if the first is strawberry, second is grape, that's 27 out of 132. First one's strawberry, second one's strawberry is 6 out of 132. Here's a good place to check. 72 plus 27 plus 27 plus 6. Make sure that adds up to 132. Now, let's answer this question. She must be like me. I love strawberry. And so she's wanting exactly 2 strawberry candies. And we can look right here. This is the path of 2 pieces of candy that were specifically strawberry. So this is the probability of strawberry and strawberry. The first and the second are strawberry. To add a decimal to it, or percentage, we take 6 divided by 132. Excuse me. And we get about 0.045, which is about 4.5%. So not very likely that she will get 2 strawberry candies. She should just open the lid and look for the strawberry. Or open her eyes and look for those strawberry pieces. So please make sure you reach out to me if you have questions, and thank you for watching this video.